Good day, students. Welcome to part one of the THEA practice test. This document you can get on the www.thea.nestinc.com website. It has all the questions and also the answer key. Okay, so we're going to be going over questions 1 to 10 on this review series. Let's go ahead and take a look at question number 1. It says a machine in a soft drink bottling factory caps 3 bottles per second. How many bottles can it cap in 15 hours? So 3 bottles per second, how many bottles can it cap in 15 hours? Well, all we need to do here is basically figure out how many seconds 15 hours is, and then we'll multiply by 3 since it is 3 bottles every second. Okay, so uh, 15 hours. 15 hours in 15, how many minutes do we have in an hour? We have 60 minutes in an hour, right? So we have 60 minutes per hour. And then how many seconds do we have in a minute? We have 60 seconds in a minute, all right? So in order to convert hours to minutes, we just need to multiply by 60 times 60, or 3,600. And if you notice what happens with the units here, you notice that this hour cancels out, and then this minutes here cancel out, and you're left with seconds. Okay, so 15 times 60 times 60 will give us the amount of seconds that is contained in 15 hours. All right, so we're allowed to use a calculator of this nature on this test. A basic calculator with adding, subtraction, multiplying, and dividing, and squared and percentage. So let's do the computation. 15 times 60 times 60. The answer is 5,400 seconds. I'm sorry, 54,000 seconds. So this equals 54,000 seconds. Now we have 54,000 seconds in 15 hours. So if you do 3 bottles per each second, how many bottles can you do in 54,000 seconds? All you just simply do is you're going to multiply 3 times 54,000. Okay, so you have 3 bottles per second. You just multiplied by 54,000 seconds in order to get the number of bottles you're going to have. All right, you notice the seconds cancel out, and then 3 times 54,000, let's do the calculation, times 3 equals 162,000. Okay, so it equals 162,000. Now the options are provided to us in scientific notation. So the question is, how do I express 162,000 in scientific notation? Now remember, whenever you're moving your decimal points to the front of the number, you're gonna be adding to the 10, okay? And then when you're moving your decimal point to the back, you're gonna be subtracting from the power of 10, okay? Whatever the power of 10 is. So in our scientific notation, there must be only one digit in front of the decimal. So I'm going to start from the back of the number, and I'm going to move my decimal point a certain number of times, and this is my target. This is my stop point, okay? So I'm going to go 1, 2, 3, 4, 5, and stop, okay? So you notice I moved it 5 places to the front. Okay, so it's as though I divided by 10 to the 5th. So in order to compensate for that, I need to multiply this number by 10 to the 5th power. Okay, so 162,000 is the same thing as 1.62 times 10 to the 5th power. Okay, this 5 is because I moved the decimal point forward 5 times. How did I move it back to accomplish this? Is going to be a negative here. All right, so our answer is option letter D. All right, let's move along to number 2. It says a truck has 50 gallons of tank. It uses 7¼ gallons on the first part of the journey, 13½ on the second, 15¼ on the third. How many gallons remain in the tank? So we start out with 50. We take out 7¼ and we take out 13½, and then we'll take out 15¼ So whatever we get after subtracting these mixed numbers from this number will be what we have left. Okay. All right. So let's express this as a improper fraction, so we can find the LCD. So we have 50 minus To make this improper, I'll multiply the 407 and then add to the numerator. Okay, so 4 times 7 is 28 plus 1 is 29. 29 over 4 minus 2 times 3 is 26 plus 1 is 27. 27 over 2 minus 5 times 14. 14 times 4. 15 times 4 is 60 plus 1 is 61. Okay. All right, so let's make the 50 a fraction too so they'll match. Now, what's the LCD of 1, 4, and 2? The smallest number that 1, 4, and 2 can go into is 4 because 2 goes into 4, 4 goes into itself, and 1 goes into every number. All right? So I need all the denominators to be 4. To accomplish that, I need to multiply this by 4 top and bottom. This is already 4, so leave it alone. This needs to be 4. So what do I multiply this by to get 4? I multiply by 2 top and bottom. This is already 4, so leave it alone. Okay? So we're going to have 200 over 4 minus 29 over 4 minus 54 over 4 minus 61 over 4. Okay? So all you do is you just simply subtract the numerator and combine the denominator as 1, 4. Okay? So let's evaluate the difference there. So 200 minus 29 minus 54 minus 61 equals 56. And when I divide 50, just put it 56 here. 56 divided by 4, 4 goes into 5 once and 16 4 times. So the answer is 14. All right, so the answer is option A. All right, let's move on to question number 3. It says a rancher is planning to put up 220 yards of fencing. In the morning, she puts up 80 yards, and in the afternoon, she puts up 40% of the remaining fence. What percent of fence did she put up that day? Okay, so let's say this is the entire fencing that she has, which is the entire thing is 220 yards, right? So from here all the way to there is 220. So first of all, she put up 80 yards. Okay. So if she puts up 80, how many does she have left? She has 220 minus 80 left, right? 220 minus 80. All right, let's do the calculation real quick. 220 minus 80 is 140. So she has 140 left. Okay. All right. So out of this 140, she puts up 40% of this 140. Okay. She puts up 40% of this 140. So what is 40% of 140? So that will tell me the amount of yards that she puts up added to 80, and then I can figure out the percentage. Okay. So let's figure out 40% of 140, which tells me how much she puts up in the afternoon. So 40% of the remaining, which is 140. How do we do this in math? Well, 40% is, you move the decimal point forward twice, 1, 2, because I'm dividing by 100. So it's going to be 0.4 of is multiplied by 0.4 times 140. That is what 40% of 140 is, okay? All right, so let's calculate that. So 0.4 times 140 equals 56 yards. So she puts up 80 in the morning and 56 in the afternoon. Okay. So how many did she put up in all? She put up 80 plus 56 yards, and if you add it up, you have 136 yards. Okay. All right, so what percentage of the whole is 136? That's what we need to do. So the percentage is whole over the part, right? So percentage is part over the whole. So we're looking for the percentage that she put up. So what part did she put up? 136 over the whole, which is 220. So we just put that in our calculator and it tells us what the percentage is, okay? So 136 is the part she put up divided by the entire piece, 220. We have 0.6. If we round it up to 2 decimal places, it's 0.62. Okay, so it equals 0.62 What is 0.62 in percentage? To write this in percentage form, all we do is move the decimal point back twice. Okay, so let's do a multiply by 100. So 0.62 equals 62%. Okay, because 0.62 is the same thing as 62 over 100, and 62 over 100 is the same thing as 62%. All right, so our answer to number 3 is option letter C. All right, let's move on to number 4. It says during a bike-a-thon, a local company pledges to donate $1.25 for every $4 pledged by the public. If the public pledges a total of $156, how much should the company donate per mile? Okay. All right, so let's see how to set this up. All right, so for this one, we're gonna set up a ratio. We're gonna have, we're gonna set up a proportion using public over private over company over public. Okay, so we're gonna have company over public. Okay. All right. So this is the first fraction is gonna be what they pledged. Okay, and then the other one's gonna be the actual figures that came in. Okay. So what did the company pledge? The company says $1.25 for how much from the public? For $4 pledged by the public. All right, and that equals in the actual donation. What actually happened was that the public pledged $156. So that goes downstairs. And the question is, how much will the company donate? So I'm going to represent that with X. Okay? So the numerators represent company, and the denominator represents public. All right? So if I solve this proportion for X, that will give me the value that a company would donate. Okay? So I have 1.25 over 4 equals X over 156. All right? To solve this equation, for X, I'll multiply both sides by 156. 156, that's the inverse of dividing, so this cancels out. So I'm going to have X equals 125 times 156 over 4. Okay? All right, so we're going to do this with a calculator. 1.25 times 156 divided by 4. Okay, so that gives us $48.75. So the company is going to donate $48.75. Answer is option B. Okay, all right, let's move along to question 5. It says use the pie charts to answer the questions as follows. This is the total expenditures and advertising. It says the first pie chart represents a company's expenditures, and the second pie chart shows a company's breakdown of company's advertising expenditures. What percentage of the company's expenditures is spent on radio advertising? So this is total. This piece right here, advertising, is broken further into this entire pie right here. Okay, so we're going to be dealing with multiple percentages. So so it says radio advertising. So we need to do radio first. Okay, answer advertising first. So percentage of advertising is basically 35% of the whole. Okay, let's say whole is the total amount. Okay, or yeah, let's use total. That's a better word as opposed to whole. So 35% of total. Okay. All right. So this expression gives me the amount spent on just advertising. Okay. But the advertising is broken further into respective percentages. So I want to take the radio percentage of the advertising. The radio percentage of the advertising is basically 18% of advertising. Okay. But I know that advertising is 35% of the total. So radio, so this is radio right here for radio. So my radio expenditure is going to basically become 18% of the amount of the total spent on advertising, which is 35% of the total. So we have double percentage here. Okay? So 18% of 35% of the total will tell me the percentage spent on advertising. Okay? So let's write this in mathematical form. 18%, you move the decimal point forward twice. So you move the decimal point forward twice to convert this to decimal. And the same goes for 35%, move it forward twice. So it's basically 0.18. Off it means you multiply 0.35%, 0.35 of the total, which is times total. Okay, so multiplying these two decimal forms will tell me the total percentage that goes to radio advertising. All right, so to do this, all we simply do is we're going to go 0.18 times 0.35, which equals 0.063. So it's going to be 0.063 multiplied by the total. Okay, so let's convert this back to percentage form. To convert this back to percentage, all we do is we're going to move the decimal point back twice. That's decimal to percent, okay? Put it back twice, so that's going to give me 6.3% of the total, okay? So 18% of 35% is 6.3%. You convert the percentages to decimal and then you multiply, okay? So your answer to this is 6.3. That's the amount, the percentage spent on radio advertising, okay? So there you have it. Okay, let's take a look at question number 6. All right, so question 6 says, scientists have stocked Wilson's pond with a species of fish. The scientists note that the population has steadily decreased over a period of time until approximately half the number of original stocked. If the number of fish are plotted on the y-axis, the amount of time on the x-axis, which of the following could result? Okay, so we're looking for a decay rate where it actually starts from a certain amount and decreases down to half the amount. Okay, so let's look at the starting amount of each of these graphs right here. 1, 2, 3, 4. This starts at 4. This starts at 1, 2, 3, 4, 5. This starts at 1, 2, 3. This starts at 0. This is absolutely wrong because this doesn't apply to this problem. Okay, because it actually started with, it didn't say we started with no fish. We actually stocked it with fishes. Okay, it started with a certain amount of fishes, so this doesn't apply. Okay, so let's see. If it reduces by half, that means that we gotta divide everything by half, right? So what is 4 divided by 2? 4 divided by 2 is 2, so this is half, 1, 2, right here. 5 divided by 2 is 2.5, so we'll go 1, 2, 2.5, right here, that's halfway. 3 divided by 2 is 1.5, right there. So which of these graphs does the graph actually descend down all the way to the midway point? It's only this, right? Because if you look at this scenario here in option A, you started at 4 and it came down to 2. And that's exactly what's happening here. You had half the original number. This one started from 5 and went down to 3. Okay? That's 2/5, or that's 2/5 of the entire decrement that's happening right there. We need 50%. This is 40% decrement right here. Okay, had it been it came down to here, it would be a candidate. So this is wrong because this decreased by 40%. This one, it didn't even decrease. This just stayed exactly the same amount. Had it come down to 1.5, then that will be correct. Okay, so basically what helps here is putting numbers to the axis and see which decrement actually matches the indicated amount here. All right, so this is 50%, which is excellent. This is half, and this is 40%, which is bad. Okay, so the answer is option A. Okay, let's take a look at question 7. It says a student receives a score of 88, 82, and 84 in 3 quizzes. If test counts twice as much as quizzes, what is the lowest score the student can get on the next test to achieve an average score of at least 80? Okay, so to do this, what we're going to do is we're going to say Let the test score be x. Okay, so when I do an average, this is going to count twice. Okay, so let's do an average. Our average is going to be 88 point plus 82 plus 84. Now the test is going to count as count twice. Okay, all right, so divided by, now since the test counts twice, instead of having 4, we're going to have divided by 5. Okay, because you have 1, 2, 3, 4, 5. All right, so that's the formula for average, the total divided by the number of elements in the sample space. That's what your average is, okay? So we're told that the average is 70. All right, so we'll solve this for our average. We'll solve this equation for x, and that will tell us what you must score on a test to score at least a 70 average, okay? All right, so let's go ahead and do this. So we're gonna add 88 plus 88 plus 82 plus 84. Let me use a calculator for this. So let's see. 88 plus 82 plus 84 equals 254. So we're going to have 254. X plus x is 2x plus 2x over 5 equals 70. Okay. All right, now to get x by itself, we'll get rid of this 5, the 254, and then the 2, okay? So it's like we're solving an algebraic equation here. So multiply both sides by 5 first. This 5 cancels with that, so we're going to have 254 plus 2x equals 350. Okay, and then we're going to subtract 254 from both sides. Subtract 254, subtract 254. And then we're going to have 2x equals 96. Divide both sides by 2. And then you have x equals 48. Okay, so our answer to this is option letter B. All right, let's move on to question 8. It says use the distribution below to answer the question that follows. All right, so this is brand A, miles per gallon. This is the mean right down the center. And basically, how wide it is basically how is a variation or deviation from the mean, okay? So we can clearly see that they both have the same averages, but brand A doesn't vary as much as brand B. Brand B has a wider variation variation or deviation from the mean compared to brand A, all right? So let's see, which one is correct? Option A. It says the mean of gas mileage brand A is greater than the mean of gas mileage B. That's wrong because they have the same mean right here. Let's see. Data collected for more. It said data was collected for more cars of brand A than for brand B. There's no reference to amount of cars that were collected here. We just know the mean and the deviation from the mean. Okay, so this is not a good option. It says brand A cars have smaller variability in gas mileage than brand B cars. So excellent. This is what we're talking about right here. We talk about variation, we're talking about the deviation from the mean. Since this is not as widespread as B, it has a smaller variation, okay, than A. So let's say brand B goes from let's say 20 to 50. What do you think brand A is going to be? It's going to be like from 30 to 40. Okay, so it has a smaller variation or deviation from the mean as compared to brand B. Okay, so this out here is brand B, which is a wider variation compared to brand A. All right, so the answer is option B. All right, let's move on to question 9. It says use the graph below to answer the question that follows. So this graph shows us some pieces of information. All these are given in slope-intercept form. So we know the slope-intercept form of the equation of the line is y equals mx plus b. If I can find the slope m and the y-intercept b on this graph, then I'll be good. Okay? So b is the y-intercept. So what is the y-intercept in this graph? 1, 2. There goes the y-intercept, right? So b is 2. So what is your slope? Slope is rise over run. Okay? Rise could be positive or negative, right? In this case, we're going to be going, starting from this point to this point. What happened? We went down 2 units, 1, 2, which is a rise of negative 2. And then we ran 1, 2, 3. So we rise 1, 2, and run 1, 2, 3. So your run is 3. Okay, so your slope is negative 2 over 3. So now I have my slope and my y-intercept. I can put them together. Y is equal to negative 2 over 3 x, which is m, plus your b, which is 2. Okay? So this option matches with option letter A. All right? Okay, let's take a look at the last question. It says, what is the slope of the line passing through 0, negative 1, and 0, negative 1, and 3, negative 2? Now, this is you can use your slope formula in your formula sheet. M is equal to y2 minus y1 over x2 minus x1. Okay? So this is x1, y1, and this is x2, y2. Alright, so let's plug this into this formula. We're going to have minus negative 2 minus negative 1 over 3 minus 0. Okay? And this comes out to 3, sorry. This comes out to negative 2 plus 1 over 3, which is negative 1 over 3. Okay? So there goes your slope. Your slope is negative 1 over 3. Answer option B. So there you have it. Well, thanks so much for taking the time to watch this video. Feel free to subscribe to my channel by clicking up here. And please post a comment to tell me what you think about this video. And more videos can be found on microchef.com. Thanks again and have a wonderful day.